Hey everyone, Professor Baldwin here. Today we're going to look at a word problem, and a word problem that turns into a quadratic equation that we need to solve. And even better, it's our favorite type of word problem, a distance, rate, time that involves an airplane, or as I like to call it, a boat in the sky. Now remember, whenever you are given a problem like this, write down what you automatically know is true about all of this type of problem. We know that it's going to be a distance, rate, time. So we can use the equation d equals r times t, or time equals distance over rate, and so on. And because it's an airplane, we know we're going to have two different scenarios. One, where we're traveling with the wind, and that would be a rate of P, the plane, plus W, the wind. And we know we're going to have a rate where we're traveling against the wind, or the plane minus the wind speed, because the plane is being slowed down by the wind. Now let's read the actual problem. A pilot flies 500 miles. So we know that our distance is going to be 500 miles. And it's against a 20 mile per hour wind. So against, our wind here is going to be 20. So our rate is going to be P minus 20. On the next day, the pilot flies back home with a 10 mile per hour tailwind. A tailwind means that it's pushing the plane, so it's going with the plane. That tells us P plus 10 for our rate when we're traveling with the wind. Then the total trip, so both ways, takes 4 hours. So T1 plus T2 has to be 4 hours. And we're asked to find the speed of the airplane without a wind. And for us, that's going to be the variable P. So now let's piece it all together. Well, we know that the time to fly there and back is 4 hours. So we want to use this equation, t equals distance over rate. So our distance over rate for the first leg of the trip plus our distance over rate for the second leg of the trip has to be 4 hours. And now we can plug in what we know about distance and rate. Well, distance is 500 miles each way. So the numerator for each of these is 500. The rate, the denominator, is what changes. The rate when we're flying with the wind is P plus 10. And the rate when we're flying against is P minus 20. So this gives us each leg of that trip. Now we have an LCD here. It's going to be each of the given denominators, P plus 10 and P minus 20. So we're going to multiply all three terms in this equation by that LCD. That'll give us a first term of 500 times P minus 20, a second term of 500 times P plus 10, equals to 4 times P plus 10 times P minus 20. Now we're going to distribute and get rid of all of our parentheses. We have 500P minus 10,000 plus 500P plus 5,000 equals 4 times I'm going to use FOIL on these binomials first. P squared plus 10p minus 20p minus 200. I can simplify the left. I combine my p's and I have 1000p. Combine my constants and I have minus 5000 equals 4 times p squared. This 10p and negative 20p simplify to negative 10p. And we multiply by the 4, so negative 40p minus 800. Now notice we're starting to get a quadratic. So we want to get it into standard form. And since we have a positive 4p squared on the right, I'm going to shift everything to the right-hand side. First, I want to subtract 1000p. And I'll also subtract that on the right. And at the same time, I'm going to add this 5,000. And I'll also add the 5,000 on the right. That brings us to 4p squared minus 1040p plus 4200 equals 0. Now notice we have a leading coefficient of 4, and our other two terms are divisible by 4. So we can factor out that 4 to make these numbers a little bit smaller. That brings us to p squared minus 260p plus 1050 equals 0. And if we divide both sides by that 4, it goes away, and we're left with solving p squared minus 260p plus 1050 equals 0. With numbers this large, I'm going to use the quadratic formula. So I need to identify my a, b, and c values. A here is 1, b is negative 260, and c is 1050. Then use the quadratic formula, which will give us the values of p, and that's negative b plus or minus the square root of b squared minus 4ac over 2 times a. Now we plug in our values for a, b, and c. Negative b would be a negative 260 plus or minus the negative 260 squared minus 4 times 1 times 1050 divided by 2 times 1. Start simplifying. Negative 260 is a positive 260 plus or minus the square root of negative 260 squared, which is 67,600, minus 4 times 1050, or 4200, divided by 2. We can combine those like terms inside the square root. We have 260 plus or minus the square root of 63,400 over 2. Now, if you get your calculator out, we have 260 plus or minus the square root of 63,400 is approximately 252. So we'll say that this is approximately equal to, and then divided by 2. Now, because of that plus or minus here in the numerator, we're going to have two possible answers. 1 is 260 plus 252 divided by 2. That would be 512 divided by 2, or 256 miles per hour. And the second is the minus, which is 260 minus 252 divided by 2, or 8 divided by 2, which is 4 miles per hour. Remember what we're solving for. P, our plane speed. Does it make sense for our plane to travel 4 miles per hour? No, I'm pretty sure we all walk faster than 4 miles per hour. So we're going to throw that answer out. And the true answer is 256 miles per hour, because it's the only one that makes sense in terms of our problem. So this is our plane without wind. It's going to travel 256 miles per hour.